Hi, I'm Nicole Deduche,
I'm Olivia Letter. I'm Anya Anito.
and our final project is the Greg Shorthand Recognition Model.
Our application is a deep learning model that can take in and identify different characters of the Greg shorthand alphabet. Greg shorthand is a phonemic writing system consisting of 25 different characters, each corresponding to a spoken sound. This eliminates silent letters, and as a result, there is no character for V. Our dataset is similar to the MNIST dataset, as each image is a square that contains one character. Our motivation to create this application is that most people cannot read or interpret Greg shorthand. Having a model that can recognize different characters can be used to translate doctor's notes written in Greg shorthand, such as prescriptions and diagnoses.
So this is how we broke down the overall design of the project. So we discussed as a group different applications, and we decided that we wanted to use the Greg shorthand model. This is because this is the idea that corresponded most to us as biomedical engineers. So we wanted to design a code that was able to read in the Greg shorthand alphabet and convert it to the corresponding letters of the English alphabet. Because there's not an actual alphabet to compare to based in the Jupyter notebooks, we had to compare ours to the MNIST dataset. So how we decided we were going to go about finding the images was we were each going to find 100 images of the alphabet and use it for reference in the code. We obtained several different versions of these images. Some were written in pen, pencil, and some were just found online, and some were drawn on the computer. So that we did this so that our model would be able to interpret any different writing style of Greg shorthand. So for the code, we loaded in the MNIST dataset as that was what we were comparing the data to. We ended up training the MNIST dataset using random forest and sequential neural network and obtained the accuracy for both of these to compare in our report. We had to reshape the images so that the network accepted it and it was able to accurately test and train them. We then created our baseline model and obtained the accuracy and loss, also to compare in the report. We pre-processed our data using MobileNet, and this allowed us to zoom in and rotate the images so that they were all the same and consistent throughout the entire training set. We used train generator to find out how many images belong to each class, and from there we were able to explore the data. Since there were 25 different classes, each letter had to correspond to a different one in a dictionary so that it was able to accurately interpret these throughout the entire training set.
For the models, we use the sequential neural network model, which is abbreviated as an SNN model. We also used a random forest model. The tools that were used were TensorFlow and the Keras package. For our methods, we started out with our baseline model, and then we trained our data, and then we tested our data. Two models were used, the sequential neural network model and the random forest model, as I said before. Model.summary was used to summarize our data.
For our baseline calculation, we got a test accuracy of 98.20% and a loss of 6.12%. This was a very high test accuracy result for us not having to change or do any exploration to the data at this point. For the data exploration, we pre-processed using the image data generator, as I had said before. And this was because then we were able to consistently zoom and rotate the images so that they were all the exact same. And it allowed us to normalize the images between -1 to 1. We used the train generator in order to characterize the classes as categorical as we needed to have each image belong to their appropriate class. And from there, we were able to find out that there was 105 images belonging to 25 different classes. So through our data exploration, it was able to take 16 images at a time and categorize them. For this, it was able to accurately categorize the images, given some were blurry and others were zoomed in more than the rest of the data sets. But from these results, the code accurately interpreted each of the different letters and correspond it to its appropriate letter in the English alphabet.
So for our data analysis labels, we used a dictionary to assign each letter to a number. So A starting at 0 and then B 1 and so on and so forth. There are only 25 letters in this specific alphabet. As we said before, there is no V. So the numbers go from 0 until 24. Then we used train generator to train the data and using these numbers, so the dictionary was used. Then we used model summary. We used our baseline model dot summary to have a summary of our data and then the model summary for the sequential data. This was because some of our other forms of summarizing the data was not working, unfortunately, so we used this instead. We used for model 1 a sequential neural network model. This was our model that evaluated some of our data, and this was model 1 used on the data. Then we used a fit model to see the accuracy. We trained our images and then had our train labels. And then this was the different data that we got. We got an accuracy of 99.98 for the sequential neural network model. These are accuracy results. Each letter has a pretty good accuracy. We have some letters such as A and E that don't have a high accuracy, like the B and C and those. Some of that is because of the fact that they looked similar to ones that were in other folders, so the accuracy was lower. But overall, we got a very high accuracy for every single number, and our model was very accurate. These are our references, and thank you so much for your time. I hope that you enjoyed this presentation and this project idea.